Alright, so now I'm going to show you how to find the determinant of a 3 by 3 matrix. Again, I'm going to show you my method, which I believe is a very easy method. So please try to be with me until the end of the video and really learn. I will show you two different type of questions. And just to say you will be doing this a lot, okay? Alright, so here's the way I do it. You can see I have written this matrix in three copies, that to just show you it clearly, okay? But it's the same matrix and we want to find the determinant of a 3 by 3 matrix, okay? All right, so first what we do is only what we care about is the first row. I always take the first row, okay? First take the first element of the first row, that is 7, okay? So take 7, multiply 7 by, delete the column that 7 is included, delete the row that 7 is included, okay? That's the first column and the first row. Look at the remaining part. Remaining part is a 2 by 2 matrix, right? Take the determinant of a 2 by 2 matrix, which is determinant of this part. 2 times 10, you multiply this here, 2 times 10 is 20, minus 4 times 1 is 4. Okay, all right, now go to the second element of that row, right? Because we only care about the first row. Now by default you will have negative here. Always remember that will be negative, doesn't matter what sign you have here, okay? So now take 4, multiply the 4 by, delete the column that 4 is included, delete the row that 4 is included. So what is the rest of the part? 6, 3, 1, 10. Okay, so now take the determinant of that 2 by 2 matrix. It's just now you don't have these parts. 6 times 10 is 60, minus 3 times 1 is 3. Okay, now that's done. Now plus by default here. Always it's plus for any problem. Now go to the third element, which is 5. 5 times, delete the column that 5 is included, delete the row that 5 is included. So now you are left with this. 6 times 4 is 24, minus 3 times 2 is 6. Okay, so now we can find the determinant. Well, this is 7 times 20 minus 4 is 16, minus 4, 60 minus 7 is 57. So you can see I always finish off the what happens inside the parentheses. 24 minus 8. 24 minus 6 is 18. Now I'm not going to simplify this. Of course you can simplify it, okay? All right, let me show you an important one. Those are not the determinants that you take. These are the type of determinants that you take. Now if you have learned linear algebra, of course you should have, because otherwise you shouldn't be taking this course, because linear algebra is a pre-requirement. But anyway, when you want to find eigenvalues, then you have to find the determinant of a 3 by 3 matrix. So here's how you do it. It's the same method, but I want to show you something important. So you consider only the first row. Let's take the first element, which is 1 minus lambda. So 1 minus lambda times, delete the row, delete the column. What's left is 2 minus, so the determinant of this 2 by 2 part is 2 minus lambda times 1 minus lambda, subtract 1 minus 1 is 1. So that's this. We are going to get longer expressions. Now by default here it's minus. Now the second element is 1 times, delete the column, delete the row. So what's left is, let's delete it really. What's left is 1 minus lambda. 1 times 1 minus lambda is 1 minus lambda. Always has parentheses for expressions, just like this. 2 times 1 is 2, negative 2. That's crucial. Now by default plus here, take the third element 2. So delete the row, delete the column, delete the row. 2 times 1 times 1 is 1 minus 2 times 2 minus lambda is 2 times 2 minus lambda. All right. Now you want to simplify this. Now I'm going to do the simplification, because you have to do this by yourself. All right, let's see what you do. Don't even touch what's outside. Finish off the parentheses first. Now I would expand these two. So how do you expand? Well, you should know that 2 times 1 is 2. 2 times negative lambda is negative 2 lambda. Negative lambda times 1 is negative lambda. Negative lambda times negative lambda is lambda square minus 1. Okay, now minus 1 doesn't matter. 1 minus lambda minus 2 here, right? Plus 2, 1 minus, okay, so minus 2, right? Here minus 2. Minus 2 times 2 is minus 4. Minus 2 times minus lambda is plus 2 lambda. Now this is important. See why I had parentheses for 2 minus lambda. It's very crucial. If you do this wrong, you will be getting everything wrong, okay? Alright, so let's simplify. So here still I would not multiply by the outside terms. So here 2 minus 1 is 1. Here negative 3 lambda plus lambda square, okay, minus here 1 minus 2 is negative 1 minus lambda. Here plus 2 times 1 minus 4 is negative 3 plus 2 lambda. Alright, now we can multiply all the parentheses. So here if you multiply this big term by this big term, what you get is 1 minus 3 lambda plus lambda square. I multiply everything by 1. Now multiply this everything by negative lambda. Negative lambda plus 3 lambda square minus lambda cube. Here multiply by negative. Be very careful with the negatives. Plus 1 plus lambda, right? Here negative 6 plus 4 lambda. This can be simplified as, now let's simplify. It's very important, okay? So constant terms first. 1 plus 1 is 2. 2 minus 6 is negative 4. Now lambda terms. Negative 3 lambda, negative 4 lambda, plus lambda is negative 3 lambda plus 4 lambda is plus lambda. Okay. Now lambda square terms. Lambda square plus 3 lambda square is 4 lambda square. That's it. Plus 4 lambda square. Now the lambda cube term is just only one cube term, so the negative lambda cube. See, you get a cubic polynomial. That's how you get a cubic polynomial from finding the determinant of a 3 by 3 matrix that has lambda. Lambda is a constant. Well, I should have mentioned that in the beginning of the video, but lambda is a constant. I guess you know what's going on here, okay? All right. So now you can see you want to factorize this. That is why we learn how to factor a cubic polynomial and why the polynomial lone division, okay? All right. So let me do just one more example. If you feel comfortable, please leave this video, but try to pause this video, try to do it by yourself, okay? This is good practice. I only care about the first row. Now take the first element, 1 plus lambda. Now then delete the column and the row. So here 2 plus lambda times 1 plus lambda minus 1 plus 1 is 1. 1 times 1 is 1, not plus. By default negative here. Now go to the second element. Delete this column, delete this row. 1 times second element is 1. Now if you delete, what you get is 1 times 1 plus lambda is 1 plus lambda. Have parentheses minus 2 times 1 is 2. Always have parentheses for these longer terms involving lambda, okay? That's a tip. Now go to the third one. That's 2. By default plus 2 here. Delete the column, delete the row. 1 times 1 is 1 minus 2 times 2 plus lambda. Okay, let's quickly finish off this. Alright, so 1 plus lambda. Expand this here. That's always going to be the steps. Okay, so 2 plus 1 is 2. 2 times lambda is 2 lambda plus lambda square minus 1. See how slow I do this, okay? Here 1 plus lambda minus 2 now, plus 2, 1 minus 2 times 2 is minus 4, minus 2 times lambda is 2 lambda. Okay, it is highly likely that you're gonna get these signs wrong, so be careful. All right. Okay, so now let's simplify the inside as much as possible. 2 minus 1 is 1. 1 plus here 3 lambda plus lambda square. Minus here 1 minus 2 is negative 1 plus lambda. Here plus 2 times 1 minus 4 is negative 3 minus 2 lambda. Okay, now we can expand finally. This multiply by this, so 1 multiply by this whole term, 1 plus 3 lambda plus lambda square. Now multiply lambda and this whole term, lambda plus 3 lambda square plus lambda cube. Multiply by minus, here plus 1, minus times lambda is minus lambda. here minus 6, 2 times negative 2 is negative 4 lambda. Okay, now the simplifying game. The constants, 1 plus 1 is 2, 2 minus 6 is minus 4. Are we doing the same problem? I don't think so, right? 3 lambda plus lambda is 4 lambda, 4 lambda minus 4 lambda, that's gone. There's another lambda. Oh, okay, let's do that again. 3 lambda plus lambda is 4 lambda, 4 lambda minus lambda is 3 lambda, 3 lambda minus 4 lambda is minus lambda. Okay, like me, just make sure twice, okay? Be careful. Lambda square plus 3 lambda square is 4 lambda square. That's all for lambda square. Yes, here you will only have a 1 lambda cube. Alright, so this is the cubic polynomial, okay? Alright, so that is how you find the determinant, and please practice them, okay? Alright, thank you.